Today we're going to conclude our review activities for converting improper fractions to mixed numbers. Remember that you only have to do the even numbered problems on this paper. So I've marked the even numbered ones as a reminder to you to only do those. Okay, let's get started. We're going to convert 59/10 to a mixed number, meaning a whole number amount with a fraction. So step one, we're going to rewrite this expression as a division expression. 59 divided by 10. Copy that down, please. When we divide a whole number by 10, we're going to rewrite the whole number with a decimal point, which I've done here. So that shows that it's 5 groups of 10, 9 ones. Then we have our decimal point, and we have no tenths. When we divide something by 10, we just move our decimal point over one spot to the left. So my decimal point is going to go from here to here. That means that 59 divided by 10 is 5 and 9/10. And I can rewrite that in fraction form like this: 5 and 9/10. So 59/10 is equivalent to 5 wholes and 9/10. We're going to rewrite 13/6 as 13 divided by 6. I can work this division problem off to the side on my scratch paper. I know that 6 goes into 13 2 times. 2 times 6 is 12. I have 1 left over. My remainder, 1, is going to be my numerator, or the top number of my fraction. And my divisor, 6, is going to be the bottom number of my fraction. So 13/6 is equivalent to 2 and 1/6. We're going to begin by rewriting this fraction as a division problem. 29 divided by 12. We need to work the problem off to the side on our scratch paper. 12 goes into 29 2 times. 2 times 12 is 24. That leaves me with a remainder of 5. 5 is going to be my numerator for my fraction, and 12 will be my denominator. So 29/12 is equivalent to 2 and 5/12. Now I can show that with an area model. I'm going to show all together 29/12, and of course I know that's going to be more than 1 whole. Okay, so here's 12/12. And here's another 12/12. That gets me up to 24/12. Then in my third whole, I'm going to shade 25/12, 26/12, 27/12, 28/12, and 29/12. So all together, I have 1 whole, 2 wholes, and 5/12. So I have 2 and 5/12, which is the same answer that I got when I worked the division problem. Okay, next we're going to work on number 8, 20/3. We can rewrite this fraction as a division expression, 20 divided by 3. Let's work the problem off to the side. 3 goes into 20 6 times. 6 times 3 is 18. So I have 2 left over. The remainder is the top number in your fraction, and your divisor is the bottom number. So 20/3 is equivalent to 6 2/3. I can show this with an area model. Here I have 3/3, or 1 whole. Then I can add another 3/3 for a total so far of 6/3, or 2 wholes. I'm just going to keep adding groups of 3/3 until I can't go any further. I'm trying to get as close to 20 as I can without going over. (15/3) is 5 wholes. Oops, and then 18/3 is 6 wholes. So if I shade all of these in, that's 3/3, 6/3, 9/3, 12/3, 15/3, 18/3, and then I need a total of 20/3, so I'm going to make one more rectangle, cut it into 3 equal pieces, and then just shade 2 of them. So this is 19/3 and 20/3. So what that means is that I've got 1 whole, 2 wholes, 3 wholes, 4, 5, 6, and then 1/3 and 2/3, 6 2/3. Okay, next I'm going to solve 9/2. Let's begin by rewriting it as a division expression, and then work the problem off to the side. 9 divided by 2 is 4. 4 times 2 is 8. I have 1 left over. So 9/2 is equivalent to 4.5. And you can double check it with an area model if you need to. Okay, friends, this is where we're going to stop for today. So you guys go ahead and complete the worksheet on your own. Let me know if you have any questions at all.